Hello everyone, welcome to my channel CISE Topper Classes. Today we are going to discuss exercise 17 trigonometrical ratios question number 21 to 34 of M.L.aggarwal class 9 mathematics. So let us start solving this exercise here in this video. Now let us solve your 21st question. If tan theta is equal to p by q, find the value of p sin theta minus q cos theta and upon p sin theta plus q cos theta. So here tan theta is given to us, so we can let a triangle here in which the perpendicular is p and the base is q, because tan theta is perpendicular by base. Let this be the theta, perpendicular is p and the base is q. By Pythagoras theorem we can find the hypotenuse of this triangle here. So the hypotenuse we can write it as under root of p square plus q square. So if we solve p sin theta minus q cos theta, p sin theta minus q cos theta divided by p sin theta plus q cos theta. So on solving this, if we put the value of sin theta here, sin theta we can write perpendicular by hypotenuse. So this will be p divided by under root p square plus q square, and cos theta will be base by hypotenuse under root p square plus q square. So if we write this, we can write p sin theta as p by under root p square plus q square minus q cos theta as q into q divided by under root p square plus q square. So here again we can write p sin theta as p by under root p square plus q square plus q into q divided by under root p square plus q square. So this part we can write as p square minus q square. On taking LCM, this will be p square plus q square into, again taking LCM, p square plus q square divided by p square plus q square. This will be cancel out, and here we will get p square minus q square divided by p square plus q square. So this is the final answer here in this question. So this is the final solution of 21st question here, and this is the final answer of this question here which we have to calculate. Now let us solve your 22nd question. If 3 cot theta is equal to 4, find the value of 5 sin theta minus 3 cos theta divided by 5 sin theta plus 3 cos theta. So if we write cot theta here, this will be 4 by 3. Means if cot theta, we know this is base by height, base by perpendicular. So from that, if we let a triangle like this, let this theta of this right angle this, and the base here is 4, height is this. So from Pythagoras theorem, we can find the hypotenuse. So this will be under root 4 square plus 3 square. So if we write, this will be 16 plus 9 equal to under root 25, which will be 5 here. If we calculate this part, we can write here 5 sin theta minus 3 cos theta divided by 5 sin theta plus 3 cos theta. So if we put the value here, this will be 5 into sin theta will be perpendicular upon hypotenuse, means 3 by 5. If we write here sin theta, this is 5 here, so this will be perpendicular upon hypotenuse, and cos theta will be 4 upon 5. We will put the value, so 5 into 3 by 5 minus 3 into 4 by 5 divided by 5 into again 3 by 5 plus 3 into 4 by 5. So here we can write this part. This will be cancel out. Again this will be cancel out. This will be 3 minus 12 by 5. 3 plus 12 by 5. So if we take the LCM here, this will be 15 minus 12 divided by 5 into 5 divided by 15 plus 12. This will be cancel out, and 15 minus 12 will be 3, and 15 plus 12 will be 27. This will be cancel out, and we will get 1 by 9. So this is the final answer here in this question. So this is the solution of the 22nd question. Now let us solve here 23 first part. If 5 cos theta minus 12 sin theta is 0 given in the question, find the value of sin theta plus cos theta and 2 cos theta minus sin theta. So firstly, this statement we will write here 5 cos theta. If you put this here, so it will be 12 sin theta. It will be positive on other side. So if you want to write tan theta, we can write sin theta divided by cos theta as 5 by 12. So this, because we know sin theta by cos theta ratio is equal to tan theta. So from here we can let a triangle like this. Let this be theta here. So 5 is the perpendicular and 12 is the base. From that, by Pythagoras theorem, we can write here hypotenuse as under root 144 plus 25. So this will be 13 here. Means hypotenuse is 13. From here, if you want to write sin theta, so sin theta will be perpendicular upon hypotenuse 5 by 13, and from here cos theta will be base by hypotenuse 12 by 13. So in this calculation part, we will put all the values divided by 2 cos theta minus sin theta. Here we will put here. So this will be sin theta. We can write 5 by 13 plus 12 by 13 divided by 2 into 12 by 13 minus sin theta. So 5 by 13. So here we can write 12 plus 5 as 17 by 13. And here this will be 24 minus 5 divided by 13. This will be cancel out 13 and 13, and we will get 17 uh, by 19. So this is the final answer here in this question, and this is the solution of 23rd first part. Now let us solve here 23rd second part. If cosec theta is 13 by 12, then find the value of 2 sin theta minus 3 cos theta divided by 4 sin theta minus 9 cos theta. So if we write here cosec theta is 13 by 12, we can write this cosec theta as 1 by sin theta also. So if we write sin theta, this will be 12 by 13. So we know sin theta is height by hypotenuse. So if we draw a triangle, let a triangle, then the height will be 12, hypotenuse will be 13, and if you want to find the base, to find the cos theta here, so base will be under root 13 square minus 12 square. So this will be under root 169 minus 144, which will be to under root of 25. So 5 is the base here. Now we will put the value here in the calculative part, which we have to find in this question. This is 2 sin theta minus 3 cos theta divided by 4 sin theta minus 9 cos theta. So on this we will put the value here. Cos theta we can find as base by hypotenuse. So this will be 5 by 13 here. And if we put the value in this part, this will be 2 sin theta, which will be 12 by 13 minus 3 cos theta, which will be 5 by 13 divided by 4 sin theta. This will be again 12 by 13 minus 9 cos theta, 5 by 13. So this we will calculate here. This will be 24 minus 15 divided by 13 into 13 divided by 12 into 4. So this will be 48 minus 45 here. So if we calculate this, this will be 9. This will be cancel out 13 and 13. 48 minus 45 will be 3. So 3 is the final answer here in this question. Means the value which we have to find in this question is 3. So this is equal to 3 here. So this is the final solution of 23rd second part. Let us solve here 24th question. If 5 sin theta is equal to 3, then find the value of sec theta minus tan theta divided by sec theta plus tan theta. So if we write sin theta, this will be 3 by 5. And we know sin theta is perpendicular by hypotenuse. So if we let a triangle like this, let this be the triangle. Theta is the angle here and perpendicular by hypotenuse. So if we want to find the base of this triangle, this will be under root of 25 minus 9. Under root of 16 will be 4, means 4 is the base here. And from there we can write the tan theta, which is perpendicular by base. So this will be 3 by 4 here. And from that only we will put the value. Sec theta also we will find here. Sec theta we know this will be hypotenuse by base. So hypotenuse is 5, base is 4. So this is the value of sec theta. We will put in the calculative part, which we have to find here. So this is sec theta minus tan theta divided by sec theta plus tan theta. So this will be, if we put the value here, sec theta is 5 by 4 minus 3 by 4 divided by 5 by 4 plus 3 by 4. So 5 minus 3 will be 2 divided by 4 into 4, 8. This will be cancelled out and we will get 1 by 4 as the final answer here in this question. So this is the solution of 24th part here. Now let us solve here 25 question. If theta is an acute angle and sin theta is equal to cos theta, then find the value of 2 tan square theta plus sin square theta minus 1. So here if we write sin theta is equal to cos theta, this is given to us. So we can write sine theta divided by cos theta as equal to 1. And from that tan theta is equal to 1. If tan theta is given as 1, so from here we can write theta is 45 degree. And then we will put the value in this part which we have to find the value. 2 tan square theta plus sine square theta minus 1. So 2 tan square theta will be 1 square plus sine square theta as sine square theta, because this is 45 degree, so we can put the value here sine square 45 degree minus 1. And we know 45 degree is sine 45 degree is 1 by under root 2. So this will be 2 plus 1 by under root 2 ka whole square minus 1. So on solving this part, we will get 2 plus 1 by 2 minus 1. This will be 1 by 2 plus 1. On taking LCM, 2, 1 plus 2 is equal to 3 by 2. So this is the final answer in this question. Is the value of this part 2 tan square theta plus sin square theta minus 1 is equal to 3 by 2. So this is the final solution of 25th question. Now let us solve our 26th question first part. We have to prove the following here. The first part is cos theta tan theta plus sin theta. So firstly we will take the LHS part. So on LHS part, this is cos theta and tan theta. We will put the value. We know tan theta ratio is sin theta by cos theta. So if we put the value of tan theta here, this will be cos theta into sin theta divided by cos theta. So this will be cancelled out and we will get sin theta here. If LHS is sin theta and we know RHS is given to us as sin theta. So from here we proved LHS is equal to RHS. Hence proved here that this part is equal to this part. So hence proved in the first part. Now let us solve the 22nd part. Here we have to prove that sin theta cot theta is equal to cos theta. So here we know the cot theta ratio is cos theta divided by sin theta. So if we put the value here, this will be sin theta into cos theta divided by sin theta. So this is the LHS left hand side here. This will be cancelled out and we will get cos theta in the left hand side. And RHS, we know it is given only cos theta. From here we proved that LHS is equal to RHS. Hence proved in this question. The statement which we have to prove is proved from this solution. So this is the solution of 26th second part. Let us solve here 26th third part, which is we have to prove that sin square theta divided by cos theta plus cos theta is equal to 1 by cos theta. So if we take the left hand side part, this is sin square theta plus cos theta and this is divided by cos theta. So if we take the LCM here, this will be sin square theta plus cos square theta divided by cos theta is the LCM. So this is 1 by cos theta is the left hand part. If we take the RHS, it is given to us as 1 by cos theta. From that we can write LHS is equal to RHS, hence proved. The statement which we have to prove, hence proved from here. So this is the solution of 26th third part. Let us solve here 27th question. If in triangle ABC angle C is 90 degree, let the triangle here like this. So this is the triangle ABC and angle C is given to us as 90 degree. And if tan A is equal to given to us, we can let the triangle 3 by 4 because tan A is perpendicular by base, so we can let here 3 as the height and 4 as the base. So from here we can find the value of hypotenuse. Hypotenuse will be under root of 4 square plus 3 squares. This will be 16 plus 9 equal to 25. So under root will be 5 here. So this is the hypotenuse here. If we want to write here sin A cos B plus cos A sin B, so we can write here firstly we will find sin A cos B and cos A sin B. So here sin A we can write perpendicular by hypotenuse. So sin A will be 3 by 5. Cos A if we want to write, this will be base by hypotenuse. So this will be 4 by 5 because from this angle we are taking. Now if we want to find the value of sin B, if we will take from this part, so perpendicular will be 4 and hypotenuse will be 5. So this will be 4 by 5. And cos B, if we want to write, this will be base by hypotenuse, which will be 3 by 5. So if we put the value here, we can solve here sin A cos B plus cos A sin B equal to 1. We have to prove. So if we take the LHS part here, if we write the values here, So this will be sin A, we know this is 3 by 5. Cos B, we know this is again 3 by 5. Plus cos A also we know 4 by 5, and sin B also we know 4 by 5. So if we write this part, this will be 9 um, divided by 25 plus 16 divided by 25. So this will be 25 by 25. This will be cancelled out here, and we know the RHS part is given to us. It is equal to 1. From here we can write our LHS is equal to RHS. Hence proved this statement from here. So this is the solution which we have to prove here only. So hence proved here, and this is the solution of 27th question here. And this is the final solution of this question. Now let us solve here 28th question. First part, in the figure given below, triangle ABC is right angled at B and a triangle BRS is right angled at R. If AC is equal to AB is given to us as 18 centimeter and BC as 7.5 centimeter, RS is also given to us as 5 centimeter. Angle BSR is x degree and angle SAB is equal to y degree. Then find tan x degree and sin y degree. So firstly we will find the value of hypotenuse here, and other also, other sides also. So for finding it, firstly, because we know in this, in triangle ARS, here this is triangle ARS and triangle ABC are similar, because these two triangles are similar here. We can write AR divided by AB is equal to here RS divided by RB. BC here. RS divided by BC. So if we put the value, this will be AR is equal to AR divided by 18 is equal to 5 divided by 7.5, and AR will be 5 into 18 divided by 7.5. We will increase 0 here, it will be 1, and here 5. So if we cancel out this part, this will be 3, 6, so 12. So 12 centimeter is the side here of AR. So this is AR is equal to 12. From that we can find the value of RB also, because it will be 18 minus 12. So 6 centimeter is the value of AR here. So this is 6 centimeter, and this is here 12 centimeter. RB is here. This is 12 centimeter and this is 6 centimeter here. From that we can find the value of AC also. By Pythagoras theorem we can find the value of AC. So this will be, if you want to find AC, AC square will be AB square plus BC square. So 18 square plus 7.5 square. So 380.25, and AC will be 19.5 centimeter. So from, because we know angle CBD, angle here CBD is equal to angle A, and angle ABD is equal to angle C. So if we have finded the value of AC here, we can write the value of tan x degree now, because tan x degree will be here perpendicular by base. So perpendicular is 6, because we know RB value we know as 6, and this will be SR divided by SR. So it is 5. So tan x degree will be 6 by 5. Now if you want to find the value of sin y, so this will be perpendicular by hypotenuse. So here perpendicular will be 7.5 and hypotenuse we have find it as 19.5. If we want to simplify it, we can simplify here. These decimals will be cancelled out and we will get 5 here. This will be 3 and 45 9. Again here 3. This will be 5 and here 13. So 5 by 13 is the value of sin y degree. So this is the final solution of 28 first part. Let us solve here 28 second part. In the figure given below, triangle ABC is right angled triangle here at B, and BD is perpendicular to AC. Then find cos of angle CBD here. We have to find the cos of angle CBD. So firstly here calculation we can take. Firstly we will let the angle CBD as x, and angle DBA will be 90 minus x, because this is a perpendicular here. So the angle of this part here, ABC, is 90. So 90 minus x will be of angle of DBA. If we will add these all three angles in the triangle here, DAB, this will be 180 degree, and here we know CBD is x degree, and DBA is 90 minus x. ADB, we know this is 90 only, so this will be cancel out, 180 degree minus 180 degree plus x, and angle DAB will be x degree. If angle DAB is x degree, then the angle DAB is equal to angle here um, DBC or CAB we can write here. So angle DAB is equal to CAB because the angle A is coming on that part. And if angle CAB is equal to x and CBD is also x, so we can write angle CBD is equal to angle CAB. From that we can find the first part, which is cos of angle CBD. So cos of angle CBD we can write that is equal to cos of angle CAB. So cos of angle CAB, we will put the value because we know from Pythagoras theorem the hypotenuse will be 13. Means the length of this part AC will be 13, and cos CAB we can write base by hypotenuse. So 12 by 13 here. And the second part which we have to find is cot of angle ABD. So if we want to find the angle of cot of ABD, calculating here cot ABD, we can write the sum of the angles here, angle D and angle C and angle B. So if we write here angle BDC plus angle DCB plus angle CBD. So this is 180 degree, and we know angle DBC. Here angle CBD is x degree. So we can write here x degree, and angle DCB is here angle BDC is 90 degree plus angle DCB we have to find from this part. So if we want to find angle DCB, on calculating this will be 90 minus x. And if angle DCB is 90 minus x, we can write this is equal to angle ACB. And we know angle ABD is 90 minus x. So from here only we can write angle ACB is equal to angle ABD, which is 90 minus x, which is equal to 90 degree minus x degree. So from here if we apply cot here, cot of angle ABD, this will be equal to cot of angle ACB. From there we can write, because cot is base by height. So this will be, we can write base is here 12 and perpendicular is 5. So from here we can write in triangle ACB. We will apply here, this will be 12 by 5. Base is 12 and angle ACB we are taking now. So this will be, base will be 5 and height will be 12. So this is the final answer here in this question. So this is the solution here. The final solution of 28 second part. Let us solve your 29 question. In that joining figure, ABCD is a rectangle. Its diagonal AC is 15 centimeter and angle ACD is alpha. If cot alpha is 3 by 2, so here we can write cot alpha will be base by hypotenuse. Base is CD by AD. So this is 3 by 2 here. From there we can write CD is equal to 3 by 2 AD. From that only we can, by Pythagoras theorem, we can write AC square is equal to DC square plus AD square. So here this is CD square also we can write. So here we'll put the value. This will be 3 by 2 AD ka whole square plus AD का whole square. AC is 15, so 15 का square. This will be 225 equal to 9 AD square plus 4 AD square divided by 4. So on adding this will be 13 AD square divided by 4 equal to 225. We will multiply this. So 225 into 4 divided by 13 is equal to AD square. So on taking the under root of this part, so AD will be under root of 225 into 4 divided by 13. So this will be 15 into 2 divided by under root 13. So 30 by under root 13 is the value of AD here. So AD is equal to 30 by under root 13. Now if we want to find the value of CD from this, so CD will be 3 by 2 into 30 by under root 13. So we can write this is 15 here. 15 into 3 will be 45 divided by under root 13. From that only we can find the perimeter and area of rectangle. So here we can write the area and perimeter. So area will be, here breadth is AD and length is DC. So AD into DC, and AD is here we have find it 30 by under root 13 into 45 divided by under root 13. So on calculating this, we can write 30 into 45 divided by 13. So on calculating this, we will get 1350 divided by 13. So on fraction, this will be 103 11 by 13. So this is the area, means the answer of the first part. Now we have to find the perimeter. So perimeter we can write 2 length plus breadth. Length here is uh, this DC is given as 45 by 13. So 45 by under root 13 plus 30 by under root 13. So we will take the LCM here 2 and under root 13 we will take the LCM, which will be 45 plus 30. So we can write 45 plus 30 as 2 into 5, and here 75 divided by under root 13. So the final answer will be 150 divided by under root 13. So this is the answer of the second part here. So this is the final solution of 29th question, and the area we have to find. So area is 103 11 by 13 centimeter square we can write, and perimeter is 150 divided by under root 3 centimeter. So this is the answer of the first and second part of this question. Let us solve a 30 question. Using the measurement given in the figure alongside, find the values of sine phi and tan theta. So here, for solving the first part, firstly we'll find the value of DC. So DC square will be the hypotenuse minus base. So we'll get DC square. So this will be 13 square minus 12 square, which will be 25. If we take the under root, DC is equal to 5. So here we have finded the value of this part, and if you want to find first part, which is sine phi will be um, Sin phi will be here perpendicular by hypotenuse. So this will be 5 by 13. And the second part which we have to find is tan theta. For finding that part, firstly we will draw a rectangle type structure in this trapezium. So here we will get on finding this, let this be E, a perpendicular. So DE will be, if we write here this BE, we can write 14 minus, this is also 5 because this forms a rectangle, so breadth will be same only. And here we will get 14 minus 5 as 9. So this will be 9 here. And if you want to find the value of here, this DE, this will be hypotenuse minus base. So this will be 169 minus 25, which will be 12. So this DE is 12 here. From that we can write tan theta as perpendicular by base. So this will be 12 by 9. So this is the final answer of the first part of 30 question. Now the second part which we have to find is write an expression for AD. We have to find the value of AD in terms of theta. So here we can write, because tan theta we can write from this part. We have not finded the value of AD. So tan theta is perpendicular, which is 12 by base. So if we simplify it, this will be 4 by 3 is the value of tan theta. And we can find the hypotenuse here. AD will be 12 square plus 9 square. This will be um, so the hypotenuse is 15 here. Now we will find the value of sine theta, which will be perpendicular here, ED divided by hypotenuse AD. So here we can write this as 12 by 15. We have to find AD in terms of, sorry, this is, we will not write AD, we have to find in terms of theta. So AD will be ED divided by sine theta. So this will be ED, we know ED is 12. So this will be 12 by sine theta. And if we want to find in the terms of cos, so cos theta we can write base by hypotenuse. So this will be AE divided by AD. So again we can write AD from that value. AD will be AE divided by cos theta. And AE we know this is 9 by cos theta. So this is the final answer. We have to write AD in terms of theta. So this we have written AD as 12 by sine theta, and here we have written AD as 9 by cos theta. So this is the final solution of first and second part of 30 question here. So this is the answer of the first part, and this is the answer of the second part. So here is the solution of the final solution of 30 question. Solve a 31 question first part. Here it is given that sin a plus cos a ka whole square plus sin a minus cos a ka whole square, we have to prove that this is equal to 2. So if we take the left hand side, we can open this bracket by formula a plus b ka whole square and a minus b ka whole square we can use here. So this will be a square plus b square plus 2ab, and here a square plus b square minus 2ab. So we can write this part as sin square a plus cos square a plus 2 sin a cos A, and here if we open, this will be sin square A plus cos square A minus 2 sin A cos A, which will be equal to 2. We have to prove. So firstly we are taking the LHS part, so this will be cancel out. 2 sin A cos A plus 2 sin A cos A and minus 2 sin A cos A. So here we can write 2 sin square A plus cos square A. So this will be 2, and here RHS is 2, so we can write LHS is equal to RHS from that. So this we have proved here, and so this is the final solution of 31 first part. Let us solve a 31 second part. Cot square A minus 1 by sin square A plus 1 is equal to 0. So we can write cot A as, cot A will be cos A divided by sin A. So this will be cos square A sin square A minus 1 by sin square A plus 1 equal to 0. So we can write cos square A minus 1 plus sin square A divided by sin square A. So on solving this, this will be 1 minus 1 divided by sin square A. So it will be 0. So the LHS part here is 0 and RHS part is given to us as 0. So hence proved that LHS is equal to RHS, and this is only we have to prove in this question. Hence proved in 31 second part. Let's solve a 31 third part. If we take the LHS part, this will be 1 by 1 plus sin A divided by cos A ka whole square plus 1 by 1 plus cos A divided by sin A ka whole square. So this part we can write 1 by cos square A plus sin square A divided by cos square A on taking LCM. Again 1 upon sin square A plus cos square A divided by sin square A. So this part we can write cos square A plus sin square A on taking LCM. Again this will be cos square A plus sin square A. So on cancelling this part, this will be 1 and RHS is equal to 1. From that we can write LHS is equal to RHS, hence proved from here 31 third part. Let's solve a 32 question. Simplify 1 minus under root 1 minus sin square theta upon 1 minus cos square theta. So this part we can write here cos square theta divided by sin square theta. So here we can write under root cot square theta. So this will be cot theta. Means answer of this 32 question is cot theta. Let's solve a 33 question. If sin theta plus cosec theta is given to us as 2, then find the value of sin square theta plus cosec square theta. So if we write sin theta plus cosec theta as 2, so on squaring both sides we can write this as sin square theta plus cosec square theta. So on squaring this part, we will get cosec square theta plus 2 sin theta divided by 1 by cosec theta equal to 4. So here we can write it as sin square theta plus cosec square theta, because 2 sin theta and cosec theta we have to write here. So this will be, sorry, this is sin theta. Cosec theta inverse on ratio we can take 1 by sin theta. This will be cancelled out and here we will get 2 plus 2 equal to 4. So from that we can write sin square theta plus cosec square theta is equal to 4 minus 2, which is equal to 2. So this is the final answer in this question which we have to find. This is the solution of 33rd question. Let us solve a 34th question. If x is equal to a cos theta plus b sin theta and y is equal to a sin theta minus b cos theta, so we can write, if we have to find ax square plus y square. So we can take the square of both these statements, b sin theta ka whole square plus a sin theta minus b cos theta ka whole square. So this will be a square cos square theta plus b square sin square theta plus 2a cos theta into b sin theta, again a square sin square theta plus b square cos square theta minus 2a sin theta into b cos theta. So this will be cancel out here. 2ab sin theta cos theta, and here also 2ab sin theta cos theta. So here we will get on taking common a square, this will be cos square theta plus sin square theta, and here on taking b square common, this will be sin square theta plus cos square theta. So we will get here, because the value of cos square theta plus sin square theta is 1, so I'll put here a square into 1 plus b square into 1. So the final solution is a square plus b square, which we have to prove in this question, hence proved from here. So this is the last question solution of this exercise 17, 34th question.
Thank you for watching my video. If you like this video, please like, share and subscribe my channel.